naman tayong bagong project. Ano na naman yan? Ba? Ito ang bago nating project. Wireless LED. Ito yung kanya receiver. Okay, LED. At meron tayo ditong transmitter. ABCD. Okay? Pindutin. Umiilaw siya. Atras. Yan ang bago kong magic. Magic na naman kapakasimple naman ang ginagawa mo. Ba? Transmitter, receiver, siya ay radio signal, 315 MHz. Yan ang bago nating project. Diba? Siya ay momentary o retrievable. Pag pinindot mo, nirelease mo, wala. Yun, momentary. Diba? Magic na magic yan. Simpleng-simple naman yan. This is now the circuit diagram of our project. In our diagram, we are using this module. This is a receiver module, and then we have this transmitter module or the remote control, consisting of A, B, C, D key. We have this pin out from the receiver module. Ground 5 volts, D sub 0, D1, D2, D3, and then the BT. This 315 MHz is a radio signal. So we're using a radio frequency of 315 MHz. 5 volts is connected to the 5 volts pin out, and then ground to the ground. And this D sub 0, we connected this LED module. I made this LED module composed of resistor and then the LED. So when we press the button, which is button B connected to the D sub 0. When we press the button, the transmitter, which is the remote control I use, emits a signal and being received by the receiver. So this is RX. This one is TX. The signal travels to the air. So if this is a radio frequency signal, this is not a line of sight, because the characteristic of a radio signal is it reflects to any surfaces. This is not a line of sight. LOS. Unlike the remote control of the TV, that is a line of sight. or the infrared remote control. This is not a line of sight. So the signal travels into the air and being received by the receiver, this radio frequency module, and then processed by the module, and then current flows into the out. There's a current out into the resistor and to the LED red. It will turn on the LED every time we press the button. And if we release the button, LED turns off. So the characteristic of this type, we are repairing this as a wireless switch. We are using this type of operation as a wireless switch. We use this module as a wireless switch. Every time we press the button B, that is in the keypad, LED turns on, and if we release our finger to the button, it will turn off the LED. When you press it, it will turn on, and when you release it, it will turn off. Momentary. This is now our circuit. We have the 9-volt supply, and then 5 volts converter, converting 9 volts into 5 volts, and then we have this 555 timer. Press the button. Okay, it is a momentary switch. But because we have a new circuit, we're going to adjust a delay, introduce a delay. It becomes a stable mode. One shot multi-vibrator with the delay timer. Again, adjust. Let us take a quick look or the operation of the circuit. So we have this 9 volts battery. This is now our new power supply, and it is converted into 5 volts with the use of this voltage converter. From 9 volts it becomes 5 volts to the output. 5 volts, this is the input, ground, and the output of the 7805 voltage converter, converting the 9 volts into 5 volts. Why we convert this 9 volts to 5 volts? Because the supply of the receiver is 5 volts, and also for the 555 timer. Now we have two resistors. They are act as or serve as a stabilizer, voltage stabilizer for the input and for the output. And then this output of the 7805 is connected to the pin number 8 of this timer. What is the use of this LMC 555 timer? The use of this LMC 555 timer is a monostable or a timer, delay timer for the LED. And this one is as a wireless switch or radio frequency wireless switch RF module. And then also powering this receiver 5 volts then to the ground. Powering also this 555 timer. Pin number 8 is the power supply of the 555 timer. Pin number 4 reset, connected to the supply of 5 volts from the output of 7805. And in order not to reset the circuit. And then we have this pin number 2, the triggering pin or trigger pin. Connected is the 10K, connected to the collector emitter of this BJT and PN transistor. And the output of the receiver is connected to the base via 1K resistor. biasing resistor. If there's no base current here, the transistor is open. If there's a base current here, no base current, the transistor is open. If there's a triggering current, transistor will operate as a closed switch. It will close if the current flows into the collector to the emitter. And then pin number 7 is the discharge pin. Pin number 6 is the threshold connected to the capacitor. What's the use of this capacitor? This is the one controlling the timing of the LED, holding the period in which the LED is on. Connected to the 5 volts is the variable resistor. This is the one we are using. We adjust this potentiometer 500 kilo ohms by turning the knob using a screwdriver. Then we have pin number 3, that is the output of the LED. Pin number 5, control voltage connected to the ground. That is to stabilize the IC. Pin number 1 is the ground. Initial state of the circuit, that capacitor is discharging through pin number 6 and pin number 7. And so if it is discharging, it flows into the ground, making this output to turn off. So initially, LED is off. When we have this transmitter, when we push the button, received by the receiver, transmitting the signal, received by the receiver, and then now current flows into the out or the DO to the base of the transistor, triggering the base current or triggering to switch on this transistor. If this transistor switch on, the trigger pin of the IC, it pulls down to the ground. There's a base current here. The current will flow also into the pin number 2, then 10K to the collector to emitter, switching this transistor on, pulling it down to the ground. Or we are applying a negative or the negative edge triggering pulse. This is a low level triggering. We pull it down to the ground to work with this IC. And then what happens is, when we have this triggering base current to the transistor, it will switch on the transistor, and now the capacitor starts to charge. Since the LED now is turning on, it is now on. Okay, on with a certain period because the current flows into the resistor, into the capacitor. The value of the resistor and the capacitor now is the one that will make this transistor or this LED to turn on. The delay time. Okay, how much time will this LED still turning on? Depends on the value of the charging of the capacitor and the resistor. And then there comes a time that the resistor is well charged through 2/3 by BCC. It will now go back to the initial state, or it will turn off the LED. So the two elements for timing constant, for the timing constant of the LED depends on the resistor and the capacitor. That's why LED is turning on and then turning off. I already made a revision to the circuit. The power LED is now connected to the 9 volts. This is the revision, and also the 10K is connected to the positive 5 volts and to the pin 2. This is pull up resistor, so when there's a current into the base of the transistor, it will pull down to the ground.